So, number 5 says we have a person standing on top of a 13-foot high sand pile that wishes to estimate the width of the pile. So, whatever this might look like, the height is right here. He visually locates 2 rocks on the ground at the base of the sand pile. The rocks are on opposite sides. So we've got a rock over here, a rock over here. And remember, he's standing up at the top. The angle of depression from the top of the sand pile to each of the rocks are 19 and 25 degrees. So an angle of depression has to start from a horizontal line going down. So one angle is 19 degrees, one is 25 degrees. How far apart are the rocks? So we could assume this is a right angle. Then essentially we have 2 separate right triangles. And we have to find each of those so that we can then at the end add them together to get the total distance. What did you do first? We need an angle in the triangle, don't we? If this is 19 degrees, what's the angle in the triangle? So then from there, x is opposite, 13 is adjacent. Which trig function involves opposite and adjacent? So I could say the tangent of 71 degrees equals my opposite side to x over my adjacent side, 13. You multiply over your 13. Make sure you are in degree mode. So we get 37.7547. Over here, if that angle is 25, then 90 minus 25, 65. So we have the tangent, 65 degrees, equals the opposite side y over the adjacent side, 13. So if we multiply over the 13, then that side is 27.8786. So then you add those 2 together, and we get our final total. I think on my answer key, I rounded to 2 decimal places because I did say give your final answer with significant digits. We can see in the problem these are all 2 significant digits, and so when you do that, it's 65.6, so 2 significant digits, we call it 66 feet. Number 6, we have a 76.0 foot. So how many significant digits is that? 760, that would be 3. So that's the flagpole. Where does the shadow go? We want the angle of elevation of the sun. So an angle of depression starts from a horizontal side going down. An angle of elevation is from a horizontal going up. So it's this angle here. So again, that's opposite and adjacent. So we could say the tangent of theta equals the opposite side over the adjacent side. Then if we don't know an angle, how do we find it? Inverse. So you type in tangent inverse. So we get 53.1 degrees because I said significant digits. Problem number 12. A lawn sprinkler is located at the corner of the yard. The sprinkler is set to rotate through 90 degrees, so that's my angle. And it projects out 53 feet. So what does the 53 represent? How far in the center. What's the area of the yard watered by the sprinkler? So yesterday I put all those formulas up on the board, which will be given to you on the test. Area of a sector or portion of a circle is 1/2 r squared theta. But if you're going to use this, what does theta have to be measured in? Radians. 90 degrees is what in radians? So we have 1/2 times 53 squared times pi over 2. You could answer a couple different ways. If you left it in terms of pi, 702.25 pi. If you multiply out the pi, 2,206.18. Either way, it's area, which is square feet. Problem 13. The radius is 5. 13 revolutions per minute. Okay, couple different ways you could set that up. You could go ahead and call it an omega, or you could separate it into a theta and a t. Both ways will work. A revolution means you go all the way around the circle. So what is your angle if you do that? Except we need to go to radians. So every time you go around is 2 pi. So if we go around 13 times, that's just 13 times 2 pi. So my angle is 26 pi. My time, it was per minute, so 1 minute. I need v, linear velocity. I have two options. V equals s over t, but I don't have s, or v equals r omega, but I don't have omega. So I'm going to have to use two formulas, no matter what. Let's say I want to do v equals r omega. Before I can get there, I have to get omega, and omega is just theta over t. So that would be 26 pi over 1, or 26 pi. So then v equals r times omega. So that gives me 130 pi. My units are, my radius was in feet. It's a speed per, my time was in minutes. So 130 pi feet per minute. And problem 14. Find the remaining sides of a 30, 60, 90 triangle if the longest side is 11. So I know I have a right triangle. One angle is 30 degrees, one angle is 60 degrees. Where does the longest side go? Okay, so then you can call these sides whatever you want. I'm just going to call them x and y for the sake of labeling. So if I wanted to find x, you pick an angle to view from. So if I viewed from my 30, x is opposite, 11 is hypotenuse. So opposite and hypotenuse is sine of 30 degrees equals x over 11. Sine of 30 degrees is 1/2. Multiply over 11, so x is 11 over 2. If I want to find y, you could use the 60, or we could just stick with the 30. Now it's adjacent and hypotenuse, so I could say the cosine of 30 equals my adjacent side, y, over my hypotenuse, 11. Hand trick, cosine of 30, radical 3 over 2. So multiply over the 11, and we get 11 radical 3 over 2. Anything else on 1 through 15?